Hi everybody, another percent ratio proportion part to whole application of data. Messed that up. Let me go back to our screen so you can actually see what it was we were doing here. There we go. You got a glimpse of all the other notes that I've been keeping here. Anyway, Dave Moraine here. You got the information at the top of the screen, how to access my videos and blog, etc., etc., and follow me on Twitter if you'd like. It's a little more sophisticated application of percents, but again, dealing with the idea of percent of a percent, and the biggest ideas involved, which have to do with determining what is the percent of. When I was younger, it would be called the base, what the percent is based on. But it could just as easily be termed the whole. And here we go. We have a survey of high school students. No number given. I'm using the variable S to represent the number of such students surveyed. And we're given 3 pieces of data. And this is now going to be typical of the newer SAT and assessments that will be asking students to examine data, make sense out of it, and represent it and solve problems related to it. In this case, we're dealing with a population that's broken down both by gender, male, female, and by handedness, left-handed versus right-handed. We're not considering ambidextrous in this problem, so we'll assume it's the dominant hand we're talking about. Anyway, 3 pieces of data. 70% of the left-handed students surveyed were boys, and again, there's a lot of meat in that piece of information. And the key, again, is having students focus on the word of and what comes after it. So, see if I can get that going. Here we go. Of the left-handed students surveyed. Of the left-handed students surveyed. And that's the boys. And then 40% of those surveyed were boys, and again, it's of those surveyed. But this is different from the first piece of information. In condition 1, it was a percentage of just the left-handed students who were surveyed. Condition 2 is out of all those who were surveyed. And again, condition 3, out of all those who were surveyed. There are many different models to represent the data. Students under pressure or when they are tackling problems like this tend to be pretty scattered. It takes a lot of training to develop an organized approach and use models that are efficient and reliable. The tree branching model that I'm using in the beginning here is not my preferred model, but it is similar to what I did on a previous video, and then we'll move on to the table approach, which is, in my opinion, easier to work with. So let's look at the model. Oh, and what is the question asking? That would be helpful. What percent of the girls surveyed? Again, so critical for the students to focus. I like to circle. Focus on what is the percentage out of. The percent is based on just the girls who were surveyed. So I could have added other pieces to the tree here. I'm calling this a double tree model, but it doesn't have any real name. I'm just making that up. Anyway, on the left side, we're dealing with the left-handed students because this corresponds to condition number 1 up above here. 70% of the left-handed students. And the left-handed students represent only 10% of those who were surveyed. That comes from condition 3. So we'll see how these two conditions play out. Condition 2 will be used on the right side of this tree model. So since 90% of those surveyed were right-handed, that leaves 10% of S left-handed. And this 10% is kind of like the base or the whole, even though it's not the full 100% of those surveyed, it will be the base for the percents we are using here. In this particular case, we know that the boys were 70% of the left-handed students, so I use LB. Left-handed boys, 70% not of the whole S, but 10% of S. Changing it to a decimal, 0.07, and reconverting it to 7% of S. So that means that the left-handed boys in the survey represented 7%. Of course, that leaves 3% for the left-handed girls. 7 plus 3 has to equal the root of our tree here, which is sometimes called the node, 10%. But we're going to calculate that to verify it. So the right branch left-handed girls, they would represent 30% of the left-handers who were surveyed. And again, how do we know that? Well, 70% were boys, so the remaining 30% of this group, lefties surveyed, were girls. So the left-handed girls represent 30% of the 10%. Again, that becomes 3% of those surveyed. And we see 7%, 3% adds up to 10%. That's characteristic of all these tree models. On the right-hand side, I'm focusing on the girls since that's what the question is asking. What percent of the girls surveyed? And since the boys represented 40% of all those surveyed, the girls represent the remaining 60%. That's what this is over here. And the girls break into two categories, left-handed girls, right-handed girls. We know the left-handed girls are 3% because we just computed that from here. Since these 2% have to add up to the base, in this case the 60%, who are girls, that leaves 57%. Again, what does the 57% represent? It means 50% of all those surveyed are right-handed girls. How did we get 57%? These 2% have to add up to the whole, in this case the whole being all the girls surveyed. We could have computed that another way. The question is asking what percent of the girls surveyed were right-handed. That means we're being asked to form the ratio right-handed girls to girls. The right-handed girls are what fractional part of all girls surveyed. The right-handed girls are what percent of all those surveyed. All these many ways of expressing the same idea. Of the girls surveyed, what percent were right-handed? Students have to be comfortable with the variety of ways these questions might be asked. Forming the ratio right-handed girls to girls, we have 57% to 60%. The percents drop out since they're each divided by 100. So we're left with 57 divided by 60, which reduces to 19/20 or 95%, and there's our answer. Pretty involved, complicated. I do like tree models to represent part and whole, but because the total population of those surveyed were broken down by different characteristics, gender versus handedness, a table approach is, in my opinion, recommended here. So let's look at that table approach. I've repeated the conditions, we've set up a chart, and as is typical of many percent problems, since we do not know the numerical quantity, the actual number of the total students surveyed, we are free to choose a value, and we normally pick 100 for percent questions. We put that here. Total number surveyed. The rows going across are boys, girls, and total. Columns coming down are left-handed, righties, and total again. Let's see how this table approach makes it easier for students to represent the information. Let's see what I filled in so far. Where did this 40 come from? 40% of those surveyed were boys. Well, sorry about that. Push the save button. Where was I here? 40, sorry about that. Let's get back to this. 40% of those surveyed were boys, so we put the 40. Learning how to use this, and you can see I'm not that good at it. Keep touching that page. Alright, let's close that page. Let's get this off the screen. Now we have it. Alright, so 40% are boys. So 40 out of 100 are boys. We put that in the total column for boys. Total boys, where the boy row meets the total column. Now, where did the 90 come from? 90% of those surveyed were right-handed, so the total number of right-handed is 90. Total boys, 40. What have we not yet used? That's right, the 70%. We'll get to that in a moment. The table helps us to see the relationships among the data values more clearly. Immediately we could see that the number of girls is 60 and the number of lefties is 10. The numbers have to add up horizontally and they have to add vertically to the total. 10 plus 90 is 100, 40 plus 60 is 100. Now we've actually used most of the information given. The 40% of those surveyed were boys, we've used that. The 90% of those surveyed right-handed, we've used that. Now, 70% of the left-handed students. So we need to take 70% of the lefties. 0.7 times 10. We would hope that students would see this mentally. So 7 students are left-handed boys. That leaves 3 students who are left-handed girls. We're interested in right-handed girls, so that's 57. Because we know the total number of girls is 60 based on the 100 in the survey. Are we done? Well, we didn't fill in the right-handed boys, but not that interested in that. What we do want is to answer the question. Do you remember what the question was? Let's look back at it. What percent of the girls surveyed were right-handed? What percent of the girls, 60, who were surveyed, are right-handed? Right-handed girls. What percent of 60 is 57? Guess what? We're back to the same result we had from the tree model. Divide the numerator and denominator by 3, 19/20ths. See, I don't reach for the calculator to divide. And multiply by 5 over 5, 95 over 100. Again, the power of mental math, right? We believe that, don't we? 95%. Thank you.